This is question number 19 of practice homework 2 for session 2 on risk return trade-off. So we know asset W has an expected return of 13.6% and a beta of 1.7. If the risk-free rate is 5.1%, complete the following table for portfolios of asset W and a risk-free asset. Look at the rounding requirement. Do not round intermediate calculations. Enter your expected return answers as a percent rounded to 2 decimal places. Enter your beta answers to 3 decimal places. So first thing I would like to do is to put everything in my Excel worksheet. So you see that, let me highlight this. So asset, we have two types of asset, right? W and risk-free asset. And we are told the expected return for each asset, right? And beta. So W has expected return of 13.6% and beta is 1.7, and risk-free rate has 5.1%, and obviously beta is 0, right? So the portfolio, given the different portfolio weight, we can calculate the portfolio return. And we know that the portfolio, so this is the portfolio weight in asset W, right? So portfolio expected return is basically the weighted average of the expected returns of each individual assets within the portfolio. And the weight is simply the proportion of the wealth invested in individual asset. So portfolio expected return given the weight here can be written as this is the weight on W asset, right? Asset W. So multiply by the expected return for asset, right? So this will be times return. I want to fix the sale value for return because later on I want to drag the sale to the other portfolio weights, and Excel will automatically calculate the portfolio expected return for me. But we are not done yet. So because this is only the portfolio weight on asset W multiplied by the expected return on asset W, right? We still need to use 1 minus the portfolio weight on asset W, which is the portfolio weight on the risk-free asset, and then multiply by the expected return on risk-free asset. And again, I want to fix the sale value for the expected return for the risk-free asset because later on I want to drag the sale to the other portfolio weights. And I want to keep 2 decimal places, right, by following this rounding requirement. And portfolio beta, similarly, portfolio beta, if you look at my lecture slides, right, portfolio beta basically is also a weighted average of the betas of individual securities in that portfolio. And the weights here are the same as the weights when we calculate expected return of a portfolio. Right, so it's going to be the weight on the asset W times the beta of asset W. Again, I want to fix this sale value here because later on I want to drag the sale to the other portfolio weights, so that can automatically calculate the portfolio beta for me. So plus 1 minus the portfolio weight on asset W and multiply by the beta of the risk-free asset, right? So that will give me the portfolio beta. So I want to fix the sale value for the risk-free beta of a risk-free asset. And following the rounding requirement, I want to keep 3 decimal places. So now I can just choose these 2 cells and drag them to the other portfolio weights. And so now you can see the Excel will automatically calculate this expected return of the portfolio and the beta of the portfolio for me. So I can just copy the number back. So this might take a while. So let me just Okay, so I'm done copying all those numbers back to Connect. So the last part of the question, if you plot the relationship between portfolio expected return and portfolio beta, what is the slope of the line that results? It's actually asking a very general question because we know that the slope of that this is so-called the security market line, right? Because the security market line basically is plotting the expected return on the beta. Regardless of whether it's an individual asset or portfolio, that security market line will be the same. And we know that the slope, right? This is the beta here is the horizontal axis, and Ri here is the vertical axis. So the slope of this security market line will be simply be the term within of this parenthesis, which is the market risk premium, right? So and the risk-free rate is given. So in order to know the market risk premium, we just need to know the expected return on the market. And how can we solve out that? We can just use the relationship, right? It's gonna be RW equals RF, right? That's gonna be the campaign model. Beta times RM minus RF. So from this equation, we can solve out RM. If I move RF to the left-hand side, this will be equal to RW minus RF time equals beta times RM minus RF. And then if I divide both sides by beta and switch the sides of the equation, then that will become RM minus RF equals RW minus RF, right? And divided by beta. And don't forget to add a parenthesis here because we want to do the deduction before we do the division. And then I move the RF on the left-hand side of the equation to the other side. So now I can solve out. Actually, I don't need to solve out, right? Because this RM minus RF is basically the market risk premium, right? So that's the market risk premium, and that's the slope, because the question is asking us what is the slope of the line that results. So basically, this is the slope. So we just need to solve the right-hand side. So, and that will give RW minus RF divided by beta. So this is the beta of W, right? Obviously. So back to the Excel file, the slope will be R, this is RW minus RF, right? And divided by the beta W. So that gives me 0.05. So now let's check whether that needs to be, and we need to keep this in decimal place, right? Sorry, in percentage, and keep 2 decimal place. So this is gonna be 5%. And now let me check my work. All right, so all right.